Hey, hello everyone. I'm Vinod Pandey and I'm here with my course on chemical kinetics. Today we'll be taking the second lecture of this course, and in this lecture we have included the topics, that is mathematical expression for instantaneous rate of reaction, few questions based on this topic, then we'll be talking about law of mass action, then few questions based on the law of mass action. So let's begin with the topic. As we have discussed in our previous lecture also, that this topic is very important for our CBSE as well as ISC board examination, and it carries minimum 5 marks in both the board examination. So if you find this channel helpful, then please do subscribe, like and share. So here is the mathematical expression for instantaneous rate of reaction. So for why we talk about mathematical expression for instantaneous rate of reaction, suppose if in any reaction, if in any reaction like rate of disappearance of reactant is given to us, then with the help of that rate of disappearance of the reactant we can easily find out what we can easily find out the rate of reaction. And sometime the rate of formation of product is given, and with the help of that rate we can easily find out the rate of reaction. Or sometime the rate of reaction only given to us, and with the help of that rate of reaction we can easily find out either the rate of disappearance of reactant or the rate of appearance or the rate of formation of product. So for this purpose we need to have a general reaction. And what is this general reaction? This general reaction, we consider it as A dot A plus B dot B, which reacts to give us what? Which reacts to give us product, that is C dot C and D dot D. So here small a, small b, small c, small d. This small a, b, c, d represents the number of moles of capital A, B, C, D that is taking part in a reaction. Like if we are talking about small a and small b, then these are what? These are the moles of A and B respectively. Like if we are talking about small c and d, then this small c and d are the number of moles of capital C and D product species. Okay, so here on the left side of the arrow the species are called as reactant, and on the right side of the arrow the species present are known as product. So like if we talk about what? If we talk about the reaction, then the reactant decreases with the span of time. मतलब यहाँ पर क्या हो रहा है कि अगर टाइम बढ़ रहा है तो रेट क्या, मतलब जो रिएक्टेंट है द रिएक्टेंट विल डिक्रीज. अब जब रिएक्टेंट कम होगा तो ये कम, जो कम हो रहा है वो कहाँ जा रहा है? दैट द डिक्रीज्ड अमाउंट इज चेंजिंग इनटू व्हाट? द डिक्रीज्ड अमाउंट इज चेंजिंग इनटू प्रोडक्ट. मतलब कि रिएक्टेंट जितने कम हो रहे हैं प्रोडक्ट उतने बढ़ रहे हैं. मतलब जिस स्पीड से, जिस रेट से रिएक्टेंट कम होंगे उसी स्पीड से क्या होंगे? प्रोडक्ट का फॉर्मेशन होगा. मतलब रेट ऑफ डिसअपीरेंस, व्हाट वी कैन कंक्लूड? वी कैन कंक्लूड दैट द रेट ऑफ disappearance of reactant is equal to the rate of appearance of product. मतलब जिस स्पीड से रिएक्टेंट घट रहा है उस स्पीड से प्रोडक्ट बढ़ रहा है. यानी कि हम ये बात भी बोल सकते हैं. सो व्हाट वी कैन कंक्लूड? अगेन वी कैन कंक्लूड दैट द रेट ऑफ डिक्रीज ऑफ रिएक्टेंट इज इक्वल टू रेट ऑफ इंक्रीज ऑफ प्रोडक्ट. मतलब जिस स्पीड से रिएक्टेंट कम होंगे उस स्पीड से प्रोडक्ट फॉर्म होंगे. अब अगर हम रिएक्टेंट की बात करें, लाइक इफ़ वी टॉक अबाउट रिएक्टेंट, सो अगर हम ए रिएक्टेंट की बात करें तो ए रिएक्टेंट अकेले नहीं घटेगा. मीन्स द रिएक्टेंट ए विल रिएक्ट विथ द रिएक्टेंट बी to form the product C and D. Means the rate with which A will decrease, B reactant will also decrease with the same rate, because A and B reacts to give us C and D, means the rate of decrease or the rate of disappearance of reactant A as well as reactant B is same. And if we talk about the product, then in that case the rate of formation of C and the rate of formation of D remains same, which means that the rate of formation of product C and D are same. मतलब जिस स्पीड से C का फॉर्मेशन होगा उसी स्पीड से D का भी फॉर्मेशन होगा. And this condition is ideal when we talk about what? When we talk about 1 mole of reactant. So here this will be what? This will be our the mathematical expression for instantaneous rate of reaction. Means here the rate of decrease of A, the rate of is equal to the rate of decrease of B, which is equal to the rate of increase in the product C, which equals to the rate of increase of product D. What does it mean here? So like if we talk about in the last expression, so here what we can have, here we are having R is equal to minus 1 upon A dA upon dt, which is equal to what? Minus 1 upon B dV upon dt, which equals to what? Which equals to 1 upon C dC upon dt, which equals to 1 upon D dd upon dt. So here if we talk about like A and B, so here we are having negative sign. And what does this negative sign indicate? This negative sign indicates that with the span of time, like जब टाइम बढ़ रहा है तो रिएक्टेंट का अमाउंट क्या होता है? द अमाउंट ऑफ रिएक्टेंट डिक्रीजेस. दैट्स वाई दिस डिक्रीज इज denoted by this negative sign. So I hope it is clear to all of you. So here one thing we should note it down, that the the rate, either it is increasing or decreasing. The rate, I am just talking about the rate. The rate of A, B, C and D, when we are talking about 1 mole, then this rate remains same. That's why we are having final expression as R is equal to minus 1 upon A dA by dt is equal to minus 1 upon B dB upon dt is equal to 1 upon C dC upon dt is equal to 1 upon D dd upon dt. रिमेंबर चिल्ड्रन, एग्ज़ाम में एक बहुत कॉमन मिस्टेक आपसे हो जाती है, दैट इज़ व्हाट? जो इक्वल का साइन है, यू मिस द इक्वल साइन ड्यूरिंग योर बोर्ड एग्जामिनेशन पेपर. आप इक्वल का साइन मिस कर देते हो और वहाँ पर नेगेटिव या पॉजिटिव मेंशन कर देते हो. And if you do in such a way, then that will be treated as wrong. So be careful while writing this mathematical expression for instantaneous rate of reaction. So here we are having few questions. Write the mathematical expression for instantaneous rate of reaction for the following reaction. So here we have a reaction, that is what? That is N2 plus 3H2 that reacts to give us 2NH3. Okay. अब हमें यहाँ पर क्या लिखना है? हमें यहाँ पर मैथमेटिकल एक्सप्रेशन लिखना है फॉर इंस्टेंटेनियस रेट ऑफ रिएक्शन. तो कैसे लिखेंगे? हाउ वी कैन राइट दिस? सो suppose here in the same way, like if we talk about what, like if we talk about in general, like अभी हमने पीछे जो एक जनरल रिएक्शन के लिए हमने डिस्कशन किया, ठीक वैसा ही हम यहाँ पर भी लेंगे. सो हियर in place of A we are having N2, and in place of small, like in place of a small a, here we are having what? Here we are having 1, and in place of B we are having H, okay, and in place of C we are having NH3, and in place of D we have nothing. Okay, so D क्या होगा? D गायब हो जाएगा. So here if we talk about the coefficient small a, b, c, d, so in this case small a will be what? In this case small a will be 1, small b will be what? Small b will be 3, and small c will be 2, and small d will be 0. So we will put these values in this equation, and then what we will have? Then we will have minus 1 by 1 dn2 upon dt is equal to minus 1 by 3 dh2 upon dt. Then we will have 1 upon 2 dNH3 upon dt. In the same way we have done for the general reaction. Now let's talk about H2O2. When H2O2 decomposes, then it decomposes to give us H2O plus half of O2. So if we wanted to write the mathematical expression for this equation or this chemical equation, then how we can write? First of all, we will apply the general, we will write down the general expression that we will have for the general reaction. Then we will replace, like here A is what? A is H2O2, and if we talk about small a, then small a is 1, and here in place of C we are having H2O, and in place of D we are having half of O2. And if we talk about small a, this then small a is 1, small b is 1, and C, sorry, here b is not there, b is 0. If we talk about C, so here C is what? C is 1 and D is equal to 1 by 2. So what will be the final expression? So if we talk about the final expression, then here we will have minus half of minus 1 upon 1 dH2O2 upon dt is equal to 1 dH2O upon dt is equal to 2 dO2 upon dt. यहाँ पर 2 इसलिए आ रहा है because here in this case what we are having 1 upon 2, and यहाँ पर d की जगह अगर हम 1 by 2 fill करेंगे, 1 by d, d की जगह 1 by 2 put करेंगे, then the 2 will be shifted to the numerator part. So it will become what? It will become 2 dO2 upon dt. So this is some kind of expression, mathematical expression for some general reaction, and on the basis of this only some question can be asked in your board examination as well as in your home examinations. Now the next topic is what? Now the next topic is law of mass action. So now what is law of mass action? Like if we talk about the law of mass action, so we used to study about this at constant temperature. So what is it? Let's know, children. Like if we talk about law of mass action, so at constant temperature the rate of reaction, remember for what we are talking about, we are talking about the rate of reaction, means the rate of reaction at constant temperature is directly proportional to the product of active masses of the reactant on which power is raised, which equals to the stoichiometric coefficient. Now what does it mean? Any idea? Now it means that if like अगर हम constant temperature की बात कर रहे हैं तो at constant temperature what condition we must satisfy the constant temperature. अगर हम constant temperature की बात कर रहे हैं तो जो rate of reaction है वो क्या होगा? वो directly proportional है. किसके directly proportional होगा? Product के. किसके product के? Product of active masses. Of active masses, किसके active masses की बात हो रही है? We are talking about the active masses of the reactant which is also having power, and this power equals to the stoichiometric coefficient of the reactant. Like here we are having what? Here we are having an example, general reaction we are having again, and this general reaction is what? This general reaction, in this general reaction small a plus small b reacts to give us what? Reacts to give us product. Okay, अब यहाँ पर क्या होता है, ये हम इसको बहुत आगे तक कैरी फॉरवर्ड करते चलते हैं, ए प्लस बी plus C plus DD and so on. It may continue further also. So here by the combination of this we will have a product. And now how we can follow this definition? If we follow this definition, so here rate of reaction is what? Rate of reaction is directly proportional to the product of active masses of the reactant, and here the product, the active masses is represented by what? Here the active masses is represented by the square bracket. Okay, so here like if we talk about the law of mass action, so here R is what? In second last expression Here R is equal to what? R is directly proportional to the product of active mass of A raised to the power A, active mass of B raised to the power B, active mass of C raised to the power C, active mass of C raised to the power C into active mass of D raised to the power D. And if this proportionality sign is removed, then here we will introduce a constant. That constant we call it as what? We call it as rate constant, which is very important for your board examinations again. So here the expression, final expression will become what? R is equal to K, A raised to the power A, B raised to the power C, C raised to the power C, D raised to the power C, and further more reactants are there, then it will be in continuation. Okay, so let's talk about few terms. Like here we are having some terms or notations. So here we are having R and K. So here R is as usual rate of reaction. K, if we talk about like K, so K is rate constant. We will also include about the rate constant because it's very important. In the next lecture we'll be talking about the rate constant also. And this square bracket represents what? This square bracket represents the active masses. Now you have to work a little on this active masses. If you have any problem, then please type in the comment box. I will go through the problem that you are facing. Now here what we can say, children, here we can say that above expression, like here in the green one, underline the green one, we call it as what? We call it as the what? Expression. And this expression we call it as what? This expression we call it as the rate law expression, right? Now the next is what? Now the next is this rate law expression. This rate law expression is determined by the experiment. Means law, rate law or law of mass action is an experimental aspect. ठीक है, ये एक्सपेरिमेंट्स पे डिपेंडेंट है, बिना मतलब एक्सपेरिमेंट्स के हम नहीं बता सकते. So this is what in law of mass action we talk about. What we talk about the reactants only. Now here we have to write down what? Here we have to write down the rate law expression for the following reaction. And what are the reaction? Like here we are having what? H2 plus I2 reacts to give 2HI. So it's very simple. What will be the rate law expression here? R will be as it is, K will be as it is. So reactants are what? Reactants are H2 and I2. So here H2 is having what? H2 is having one positive, means one positive charge, and what? I2 is also having one positive charge. Okay. In this case what we are having? In this case we can see that what? In this case ethanoic acid reacts with methyl alcohol to give us ester and water. Again what here we are having? Here we are having rate constant or rate law expression for this equation, that is what? R is equal to K and in bracket CH3COOH raised to the power 1, and in second case here C2H5OH raised to the power 1. So we have written this rate law expression for this equation. Now the last equation is what? Like if nitrogen reacts with hydrogen to give what? To give NH3, then what will be the rate law expression here? So the rate law expression will be what? R is equal to K N2 raised to the power 1 H2 raised to the power 3. So these are few questions and for which we just have applied the law of mass action. But remember, this rate law expression is the experimental aspect. Without the experiments we cannot determine anything about our subject. Now here let's talk about what? Let's talk about the numerical. I just have included only one numerical, and this is what? A plus 2B reacts to give what? 3C plus 2d. So here the rate of disappearance of B is given to us, like it is given as 1 into 10 raised to the power minus 2 moles per liter per second. What will be the rate of reaction? So here we have to find out the rate, and second what we have to find? Second we have to find out the rate of change in concentration of A and C. So here the general expression that we have written. Now what are the coefficient? Like if we talk about the coefficient of A, that is small a is 1, small b is 2, small c is 3 and small d is 2. So हम लास्ट वाले एक्सप्रेशन में क्या करेंगे? In general expression we will just put the values and we will easily come to the solution. Okay, so that's all. If you have any doubt then please type in the comment box. Thank you.